Dear students, welcome and thank you for tuning in to this video with me, Dr. Loay Al-Zube. I'm still talking about the kinematics of particle, and which is part of the Statics and Dynamics course. I am going to solve a problem in this video, and we are going to learn how to find kinematics quantities of a particle traveling along a straight path. So before we doing this, dynamics is considered to be more involved than statics. Since both we are going to take care or look at the forces applied and the body and its motion. So there's a lot of things to consider. So my advice is always to read the problem carefully and then draw any necessary diagrams and tabulate the problem data. That's very important. Then a very essential step, that's establish the coordinate system, because we are dealing with vectors, and the sign and the sense of your quantities makes a big difference. Then we go into solve the necessary equations algebraically as far as as a particle. Then you consider a set of units that there should be what you're doing, and then we look at the answer and make judgment as a common sense if our answers make sense or not. So to start with this problem, we can say, okay, we have a particle. That's a problem. We have a particle that travels along a straight line. So it's a rectilinear motion problem to the right, and that is very important now because we need to make sure that we are actually establishing our coordinate system. So to the right is very important here. So we're going to assume that this is my origin point and the object is moving to the right here to be positive. The displacement and the position is in the positive direction if we are moving to the right direction, right? So that's very important. So we have a velocity where the velocity given v equals 4t minus 3t squared meters per second. So this is a function of time. So velocity is given as a function of time here, and t in seconds. And also we said that the initial position is 0. So my s0 equals to 0. So that's the starting position at when t equals to 0. The question is asking us to find the position and acceleration. So we need to find s and a of the particle when t equals 4 seconds. We're going to use the integration and derivatives because we have that velocity as a function of time. And let's see what's going to happen with the analysis. Before we start, keep in mind that you need to first establish the positive coordinate s, and that's what we did here. So that's my position in the direction of the particle traveling. So we said we're moving to the right. So anything that's positive now, it means that it moves to the right from our initial point. So at time equals 0, I have s equals to 0, and I'm moving to the right. That's in positive sense. So also the velocity is given as a function of time. We take the derivative of it to calculate the acceleration, and also conversely we will integrate the velocity to calculate the position, and that's our plan for solving this problem. Remember, it's a polynomial. Velocity is a function of time, so we can do the derivatives and the integrations easily. So here's what's going to happen. Step 1, to find acceleration, we will derive the velocity. And if you look, a equals dv over dt. And so this is my velocity function as a function of time. I need to derive it. If you derive 4t, it's going to give you 4, t is gone, and minus will stay minus. If you derive 3t squared, you take the 2 multiplied by 3, and then t to the power 2 minus 1, and that's going to give us 6t. So this is my acceleration function now, 4 minus 6t. If I am trying to find the acceleration at time equals 4, I will substitute 4 in t here in the time, and then a is going to be minus 20 meters per second squared. You notice that it's negative, which means that the speed is decreasing. So we have deceleration, and that's very important. So you can say it's minus 20 meters per second square in the exam, or you can say 20 meters per second square deceleration, or the speed is decreasing. I would rather keep it negative and then make sure that it's very, as long as you have your notation correct, you should be all good. Okay, so we'll keep it minus 20 meters per second square, and we'll know that this acceleration that we are decreasing in we have decrease in speed. For the second part of the problem, which is the position, we'd like to calculate the distance traveled in 4 seconds. We do integration of the velocity, and assuming that the position at time equals 0 is 0, and that's from the question itself. So here's what I want to draw your attention to. So we know that velocity is always equals s over dt. To find the position, I would like to start by doing a cross product by saying that ds equals v dt, and you do this actually before you do the integration, before you start the integration, if you want to find ds, the position, and then you put your integration on both sides, and you start your integration from s0 to s, and the time for the velocity, this is a function of position, right? So we are integrating position, so you start from the initial position to the final position. This is integration of time, so you start from time 0 to time t. This is very important to understand your integration and your limits, the integration limits, and it will make things way much easier for you when you do the analysis. After constructing this here, you put s0 as ds, and then you put your velocity function, which is 4t minus 3t squared. The integration of ds is s, and then since you have s, the limits from s0 to s, this means that it's s minus s0 equals the integration of 4t is 4t squared divided by 2, which is 2t squared, and the negative goes there. The integration of 3t squared is 3t cubed to the divided by 3, which is t cubed. You know, we want to find the travel distance at time equals 4 seconds. So you substitute with t here, and then you will get your s equals to minus 32 meters, which means that we moved, this is my reference, we moved to the left actually, minus 32 meters. Or you can say that we moved 32 meters to the left, or we moved minus 32 meters. We know that the position to the right was positive. So this is the distance traveled in 4 seconds. After 4 seconds, where are we? So we probably started moving this way, and then we moved to the other side, and we are here at minus 32 meters. Or we are 32 meters away from the reference point to the left. That's how we want to make sure that you understand that. Keep in mind that we started our problem actually by saying that we start traveling to the right, and it's going to be interesting to see how can you actually find the total distance traveled, and that's something we're going to be doing in another problem. I hope that was helpful. Thank you for watching. Until the next video. Bye.